Welcome back. In this lesson, as we said, we are going to implement the KNN algorithm from scratch. So we will start from the first step, which is calculating the distance. And for now, we will calculate the distance using the Euclidean distance. So what is the Euclidean distance? The Euclidean distance, we know it from high school, but let's review it again. So if we want this distance, if this is, for example, the test point and this is one of the training points, and we want to calculate the Euclidean distance between these 2 points, then it's basically q1 minus p1 square plus q2 minus p2 squared, and then we take the square root. So this is how we calculate the Euclidean distance. It's very straightforward. It's very simple. So let's see how we can implement it in Python. So here we have a function, right, def. So this is a function, and we will call this function distance Euclidean. And the input for this function is the x train corresponding to the training data, and the x test point corresponding to the test point. And this is of course the doc string that I created for this function, so you can read it. Input the x train and x test point, and the output of course is the distance. Which distance? The distance between the test point and each point in the training data. So how we can do so? First, we will create this empty list and we will call it distances, right? And then for each row in the training data, right? So for row in range len of x train, because the length of x train will give me the number of rows I have in the training data. So I will loop over the number of rows. And for each row, so this will be 0, 1, 2, 3 until we reach 119, right? Because we have 120 examples in our training data in the iris dataset, right? So this will be 0, 1, 2, 3. So this will correspond to the index of the current row. So for each iteration, we will go to the current row by writing the current row of the x train, right? And we will call this variable current training point. Okay, and then as you can see here, we are creating a new variable called current distance, and we will initialize it by 0 because we can have more than one distance. We calculate the distance for each feature, right? If we have only one feature or only one column in our training data or in our x test, right, then we will have only one distance. But if we have more than one feature, like in the iris dataset, we had 4 features, right? So we need to calculate the distance for the first feature, calculate the distance for the second feature, calculate the distance for the third feature, and calculate the distance for the fourth feature. And after that, we will add all these distances together. And the summation of all these distances will be the distance between the current test point and the current training point. So that's why we will create this variable and call it current distance. And after that, as you can see in line 16, we have another loop, an inner loop for the columns, right? So we will loop over the columns and not the rows, right? Loop over the columns of the row. And how we can calculate the distance? We will calculate the distance using this equation, right? So for each column, we will subtract the x test point, right? And then we will get the square, just like this, right? And then we add the distances together. So here we have 2 features or 2 dimensions, but we can have more than 2 dimensions. If we have 3 dimensions, then this will be q1 minus p1 square plus q2 minus p2 square plus q3 minus p3 square, and so on, right? So this is how we calculate the distance. And after looping over all the features or all the columns, we will get the square root of the total distance, right? So after we get the total distance, we will take the square root, because this is actually not the distance, it's the square of the distance, right? Or the distance squared. So that's why we will get the square root of distance using numpy dot square root. Okay, so this will return the square root. After we finish this loop, right? So after we finish this loop, Now after that, we will append the current distance to our list here. So finally, what we will return from this function is not the current distance. We will return distances, right? So the first index will correspond to the distance between the first training point and the current test point. The second index will correspond to the distance between the second training point and the test point, and so on, right? So this is what we want to return. So that's why we are appending the distances, right? And finally, after we finish the outer loop, so after we iterate over all the rows in our training data, we will convert this list into a pandas data frame, right? By just writing bd.dataframe, and then the data is of course the distances, and we will call this column dist, right? And we will return this data frame. You can skip this line number 25, and just return the list. But if you want to perform any extra operations, then it's better to have it as a data frame. So this is the implementation of the first step for the KNN algorithm, right? So let's run it. Now, the second step is to find the nearest neighbors. So how we can do so? We will create a new function called the nearest neighbors, and this function should take the distance between the test point and each point in the training data, right? So the input for this function should be the output of this function, right? And it also takes k as an input. So what is k? It's the number of neighbors we want to get. And basically it will return df nearest. So the nearest k neighbors between the test point and the training point. This is the second step of the KNN, right? So how we can do so? It's very, very, very easy if we return it, or if the input for this function is a pandas data frame. Because in pandas, we have a function called sort values. So we can just come here and write distance point dot sort values by, and we have the column name dist. So we will just come here, sort value by dist, and the axis is 0, right? So this will return the distances sorted, right? From the nearest to the farthest. And after that, it's just a matter of taking the first k neighbors. So the df nearest, this is the data after sorting. So we will return from 0 to k, right? So we have here df nearest will contain 3 values, 4 values, 5 values, depending on k itself, right? And it will correspond to the first k neighbors or the nearest k neighbors, right? So this is the second step for the KNN algorithm. After that, we will classify the point based on a majority voting, right? So this is step number 3. So we will create a new function called voting, which takes df nearest and y train. So let's read the docstring for this function. As you can see, df nearest is a data frame that contains the nearest k neighbors between the full training data and the test point. And y train is of course the labels of the training dataset. So again, the input for this function is basically the output of this function. So we will call this function first. The output of the first function will be the input to the second function, and the output of the second function will be the input for the third function. So how we can get this majority voting? We can do it ourselves, or we can use the built-in library in Python called collections, right? So inside collections, we have a class called counter, right? So if we just give it the y train df nearest index, so this will create the counter vote, right? And inside the counter object we created, we have a function called most common, right? In order to get the majority voting, we will just go to index 0 and then to index 0 again, because it's a compound data structure as we saw in the Python course. So this is step number 3. Now we will create another function, right, called KNN from scratch, and this function should take xtrain, ytrain, xtest, and k, right? So x will correspond to the full training dataset, ytrain will correspond to the labels of the training dataset, and xtest should correspond to the full test dataset, right? And of course k is the number of neighbors. And this function should return the prediction for the whole test set based on the majority voting. So what this function will do is basically loop over all the test data So it will iterate over the test data point by point, right? And then we are calling step number 1, step number 2, and step number 3. So we will call the distance Euclidean function, right? And we will call it using the x train and the x test point, the current x test point, okay? This will return the distance point. So the distance point will be the input for the nearest neighbor along with the k. And this should return the nearest points, right? So we will use the voting function to return the y prediction point. So this is the label for the current test point. So we will append this to y predict. So finally, we will return y predict. So y predict index number 0 will correspond to the label for the test point number 0, right? So this is how we can implement the KNN algorithm from scratch. So let's run this function. And now let's test the KNN algorithm on the test dataset. Which dataset? The iris dataset, right? So here we have k equals 3, and here we are calling KNN from scratch using the normalized x train and y train, normalized x test, and k. So if we run this, you will see that we have 2, 1, 0, 2, 0, 2, and so on, right? So this will correspond to the first test point label is 2. The second test point label is 1. The third test point label is 0, and so on, right? So this is how we can implement the KNN algorithm from scratch. Now, in the next lesson, we will see how we can compare our implementation with the sklearn library and if we will get the same results or not, right? We should get the same results, right? We will see this in the next lesson. So let's go.